my name is Louis Upter. I'm a decent software engineer. Doesn't really matter where I am. I don't really know anything about hardware, and I think that's an important part of this talk. Is I'm playing with like hardware devices, I'm playing with IoT, and I don't really know anything about this. I'm really just a software engineer. So if we go on slide number 3, agenda. So this talk is going to talk about 2 related projects. One is Monolight, which is an UI for like devices like this one, which is basically like a matrix of buttons like this, okay, to control light bulbs. Light bulbs like this guy here, guy, girl, I don't know actually, this bulb. So that's like Monolight. It runs an interface on this button array. And then LightsD, which is a daemon to control the light bulbs. So this daemon talks to the light bulbs, exposes a high-level API, and I can control the light bulbs this way. So I'm gonna first talk about Monolight. So I control the bulbs through this like button array. I'm gonna give you some details about the project, and then I'm gonna talk about LightsD, which was actually most of the work, which is a daemon to talk to the bulbs. And then we're gonna have maybe some time for the discussion. So if you go on slide number 4, you have this high-level architecture diagram. So you can see that Monolight talks to both LightsD on the button array, and that's how I control the bulbs. If you get next, you see that port 1 is going to be about Monolight, port 2 is going to be about LightsD. Then on slide number 5, titled Monolight, so I just talked about like what I said, 128 buttons. Each button has like 16 levels of brightness. This is how I can like make up an UI by playing with the brightness levels. It's connected over serial. The next slide is controlling this Smartbob, which is made by this brand called LIFX. It's about 1,000 lumens bulb, so it's pretty high brightness. It's like a 70-watt light bulb. It has nice colors. It can do like all the colors. It has a nice range of whites from like 2,500 Kelvin to like 9,000 Kelvin. And those light bulbs are connected over Wi-Fi, 2.4 gigahertz. So next slide, let's have a look at the controller UI. So you have the grid. So you have like this slide should be just show a grid, okay. And then next slide, you see that the bottom row is where I wrote some functions. So like bottom row is dedicated to functions. So for example, you'll see have like on, I can like off, other functions I'll show later. So yeah, next slide like shows you like some of the functions where like they're mapped, like how it works. I could like add more things to those buttons, like for example control, like MPD, control other things. And then I have like split the array into like 4 control pads, right? So this is like one control pad here, right? And like there is like 4 sliders, and I have like some other functions at the top, right? So if you go on the next slide, you see like what each slider is. Okay, awesome. So can I make it like full screen though?
Yeah.
Like let's do for the next talk.
Maybe that's better. I don't know. I don't know how to put this full screen.
Okay, perfect. Okay, so okay.
Just use it here, not before.
Yeah. Okay, so here. Okay, so like leftmost slider is like the hue, and then saturation, brightness, temperature. So that's the HSBK color model, HSB, and then we add the temperature. So I like can increment, decrement. So for example, I can show this here. So I turn this guy off again. I'm gonna like bring up the brightness, which is here. I'm gonna change the color, which is here. I can do those 2 things at the same time. Okay. And so on, so on. Can I make it like less saturated? This one, right? So you can all see like it changed color. All right. So like that was kind of the demo. Like, see, okay, other things. Okay, like other things. I think this is like ooh, like this. I can do small functions. What's interesting to see is that I'm gonna make a smoother one. That's white. That's blue. I'm gonna. So like, what's interesting is like the board shows like the state of the bulb in like with low latency, right? That's sort of like a feature of what I did. It's like it shows really like what the status of the bulb is. It's not like, you know, predicted or something. In fact, the real status of the light bulbs is shown on the board. So for example, if I make it like, you know, transition, we can see that the sliders are moving by themselves, right? And that's not programmed. It's just like showing the real status of the light bulbs, right? Okay. One more thing I wanted to show is like how like the interface is like defined, which I think is like pretty interesting. So I'm gonna go back on GitHub.
There's no.
Oh, there is no internet. Okay.
If you wait a minute, I can put it on.
Yeah. So actually, yeah, I love to do this. If you can like do this, that would be awesome. So like the way all this is implemented is in Python. So like the program that controls the grid is in Python, and the API I made internally are pretty high level, and the way you like set your UI element on the grid is, I think, pretty interesting. It's pretty high level, and that's about it for like Monolight. On the implementation details, which you'll find on the slides. So this is Python. I've been using Python 3.5 and 3.6 with type annotations, which are awesome. So you basically like, you know, do type Python. I really encourage you to look into this if you do Python a lot. And then I use async.io, so everything is asynchronous. Ooh, awesome! Thank you so much. So I'm gonna go on my profile. So here we go. You even know like the repository architecture by the end. That's pretty awesome. So it's gonna be UI layers. So it's basically like what I'm using. No. Okay. Yeah. Space. So see, here's how the UI is defined, right? So like I do. Okay, I have like a root layer on line 49, and then I can insert some buttons. The buttons are different actions in line. So see, for example, like the alerts, you know, ping breath, which is the effect I did where it was moving slowly. There is the alert, which is the flashing I did. So see, I just like define some buttons, say where they are, define the actions. It's very like declarative. That's pretty cool. Okay, coming back to the presentation itself. Okay, wanted to like show maybe one more thing that's interesting on the with Monolight. Something I'd like to do next is like I'm just gonna show it on the sides. So imagine we had two functions, like, you know, timer and alert. So we could say like press the timer button, and then, you know, you have this at shop, which is like a timer picker, right? You'd select how much time you want on the timer, and then press the target once you have selected the time. Press an effect like alert, which is the one I played and flashed the bulb with, and then I will like run automatically, right? So like one thing I do with my light bulbs a lot is I use them as a kitchen timer. I have like bulbs all over the house. Like the kitchen timer thing is pretty nice. You know, it doesn't like blow your like eardrums. Okay, I'm gonna skip this. I talked about it already. I'm just gonna talk about like art and pop-ups. I'm using his library to talk to the button grid. It's GPL with v3. Other stuff to do. Okay, I'm gonna skip over like LightsD. I'm gonna skip this demo, but basically like this is how I will like show you the same thing but command line. So show you how to talk to LightsD, the daemon that controls the light bulbs, which runs directly on the Wi-Fi access point here. Like it has very high level API in Python. Like, you know, I will show you an example in Python again. You can just like, you know, do a decompression, and you get like, a one-liner, you get the state of the bulbs. Another one-liner, you can set, turn them off, on, do some effects. Very simple, no discovery delay, very high level. Okay, that's the current project actually. Like, what I showed you so far on the grid is really like a small amount of the work. Most of the work was in LightSD, the other project. It's in C, runs everywhere, details here. The original ideas behind LightSD were to remove like discovery delays, glitches that comes with what the LIFX manufacturer deliver to you with the light bulbs. Basically, like the bulbs are nice, but the software stack is sort of like not so good. It got a lot better in like 3 years, but like at the beginning it was really bad, and that's why I started the project. So original idea is like reduce like issues, improve the user experience. Also, I had like security in mind, right? I don't want to have light bulbs on my home network. I want light bulbs to be on a separate, dedicated, closed network. I don't want them to have access to internet. I don't want them to access anything really, right? And LightSD, by acting as a proxy, allows you to do this, right? You can isolate the bulb on the network and use LightSD as a gateway to the bulbs, right? So no cloud, no internet required, no nothing. Again, GPLv3. And like something I have in mind with this project is also like to make it accessible to people, right? This is a personal project. I'm not doing this for like profit. I'm not doing this as part of my company. I'm not doing it entirely personal. And I wanted to make it accessible. So like have good code, show good practices. I did like Python 3.6, like bleeding edge stuff. So like that's an opportunity to do this, right? Good docs. On the implementation details for LightSD, it uses LIFX as 2 APIs. One is HTTP, it goes over the cloud, and one is like on the local network. It's UDP, it's much faster, also much harder to use. So I proxy all the communications to the bulbs. I use sampling to keep track of the bulbs, right? Everything is like the bulbs themselves. You can like ask their state, set their state, but like the protocol is completely stateless, right? I need to like do sampling to like know what the state of the bulbs are, right? So I just like pull them all the time, right? And that's how I get to have lower latency. You can talk to my high-level API over TCP, Unix sockets. Basically, like my API offers you like the same kind of functionality you have with your cloud API, except there is no cloud, right? It's all on your local network. On this project, I have like some fun parts and some like more like headbanging parts. One part I like to talk about especially is like what I call like stack position, right? LightSD is actually like sort of in the middle in the stack, right? On the left, it's what I call like in lower level stuff, which are like the bulb. It's hardware, it's embedded. On the right, you have like Monolight, which is a user interface. It's in Python, it's high level, it's a GUI. It's like, there is not much, system level programming stuff. And LightSD is in the middle, it's in C. And I find it's pretty interesting because it opens up to like a wide range of topics, right? By working, and like I didn't know it would go this way when I started working on LightSD, but like it really opened up to a lot of things. I can like either go really deep down and start doing reverse engineering, start writing like firmware bits and like on the light bulbs and like do like more hardware related things, or I can go very high level and start like writing GUIs and like very high level code, right? And I found this pretty interesting. Some notes on the LIFX bulbs I wanted to share with you. If you want get them on sale, they're pretty expensive. I think this year have the best brightness and colors on the market as of today, and they beat like their competitors in this. You have to keep in mind their standby power consumption, which is still fairly high. I'm pretty pissed at like the bulbs like saying like here on the box it's like rated A when the thing like consumes 2 watts in standby. I mean if you have like like 10 light bulbs, you have like it's like if you had always one fully turned on. They have a cool LAN API, and I think they are the only vendor to do this, and it's pretty cool. Like I hope they keep it. It's pretty nice. They're not super mega open about it, but they're not really closed about it either, right? One thing though is only the first generation of bulbs doesn't crash for me, right? Everything they made after this, and they're in generation 3, basically crashes, right? They have like, I could go into the details of this, but under some Wi-Fi conditions, which always happen to me, which always happen for me, the bulb crashes, unfortunately. So really, what I wanted to say about this is like, binary blobs suck, really. I love to be able to get access to the firmware source code, and like be able to like have something more open there, so I could like debug and eventually fix what's going on, like debug, like have the opportunity to take action on this, right? Or replace their stuff with my own stuff like this, right? So really, again, like, you know, free software convention, binary blobs suck, still the case. Really, thank you. Other things I want to do on this project, you know, do time-based release, improve my CI automation, do what I call state enforcement. So basically, like in LightsD, maintain 2 versions of the light bulbs, one which is the reality, and one which is what I want. And because it's like all very janky, you know, LightsD will like always try to make what's supposed to be the reality, right? So like I have 2 views and I apply one on top of each other. And then with this, be able to do a real cool like effects API, have effects plugin. They're like really reliable, right? And stuff like this. Other things I like to do, but I will never do. Not have time. But however, like if other people want to do like, you know, firmware, like something I love to do is like be able to like debug the firmwares. And I have access to the firmwares. Just make it easier for me to like reverse engineer the API. Stuff like this. That would be awesome. Yeah, that's about it. We have like a minute left for discussion and questions. So like, please go ahead. Don't be shy. Otherwise, I have like a slide. Okay, one question here.
Yeah. So have you been in contact with the supplier of the line?
Yes, I've been in contact with the supplier.
Can you
repeat the question? Yes. So have I been in contact with the supplier about my project? Yes. Actually, yes. And they've recognized that, for example, the crashes, and they say it only affects a small amount of people, but it certainly affects me. They've been pretty nice. They don't really care about the project because I'm doing something which is like completely different from like their product, right? Their product is cloud, it works on like mobile. I'm doing a daemon in C that you have to install somewhere, right? I make it as easy as possible, but at some point you're gonna have to run an apt-get, or you're gonna have to like use OpenWRT and like, you know, put it somewhere on a Raspberry Pi, whatever you want. But you'll have to open a Hutu and type some comments, right? So they're not something, you know, they're not really interested, right? I believe, and like I totally understand this.
They're not interested to open the firmware either.
No, they're not. I also asked this question. They're clearly not interested in opening their firmware. Any other question? No. Okay. Well, thank you so much.
Sorry for all the